Welcome back. So what we'll be doing now is that we'll be assembling the whole unit now, the whole burner unit. We're assembling the knob, the shaft, the support, the rack, the pinion, and the slot with the carriage mechanisms. So go to your Solidworks and open Ctrl New, and you are clicking assembly this time around. Say OK. Alright. So the moment you get to assembly, so one of the critical things you have to ask yourself is that what's the first critical thing, which is the frame. The frame is the first thing you'll be adding in this particular assembly. So click on the frame, now bring it to the screen. Now you can see the frame. Solidworks does immediately align it to the center and lock it. So but what you want to do is to right click on it and say make it float. So the moment you float, you say the front plane of the burner should be made to the front plane of the assembly. Then the top plane of the burner should be made to the top plane of the assembly. Once you are done with it, click on it. The right plane of the burner, the right plane of the assembly. If you are done with these three first fundamental means, come back and right click on the maintenance fixed. So that stands as your reference point of the first component and is fixed there. So the next thing is to go to assembly and say insert component. So what's the next component you use to insert now, to put into this system now? Okay. For me, I will be saying let me put in my carriage assembly. So I'm browsing it, carriage mechanisms. So that's carriage mechanisms coming in. So the first thing you want to do is that you want to concentric mates between the two circular objects. That's the first edge and the second circular object. Alright. Now here, one critical thing you need to do is you need one of these holes to also make it. So, if you look at this particular one, it has a limit between minimum and maximum. The distance between here and here has a minimum value and maximum. Now, the maximum keep going up. So to do something with Solidworks, you have to go to mate, then you go to advanced mate. So there is advanced mate called linear coupler. You go to linear coupler. In linear coupler, you go to linear. So at linear, you can define the maximum and the minimum point between any two surfaces you select. So that's between that surface and that surface. Now I want the maximum distance to be 10, to be 30, and the minimum to be 2. So you can see from that screen, I can drag it up and down, the way it behaves in the real life. Alright, the next thing to put in now, let me insert my slot. So that's slot. So the surface of the slot, this surface of the slot must be mated with this surface like that, and this hole where you add the bolt to hold it also be concentric to this one. And turn it back. Alright, so this face now, so let's repeat their concentric mates again. This must be mated with this concentric, yes. Then this surface must be mated with this surface, this one. So let's look at this guy, this slot. How many mates are in this slot now? So this face must be made with this face. Then I should bring the support, this particular support to the same. So support. So this face of the support should rest on this face. And this O should be concentric with this O. Likewise, the second also should do the same thing. Alright, the next thing for me to put in now is the shaft. Is this shaft now? I need to put in this shaft now. So insert component, control shaft. So the control shaft passes through this circle, so there is a concentric mate between this and this. Concentric mate. But in the other directions, down. So the head of this guy must be coincident. The head of this, so that they can drive each other. Alright. Then the next thing to bring in is to bring the controller. Just going to be the rotation, there's a lock rotation. So as this guy continues to it, so I'm locking rotation from this surface in such a way that if I rotate this, so you can see kind of movement between them. Observe, if I rotate this, it's coming down and coming up. So that's it. So, and that's about your burner unit. So, I don't know, let me quickly add bolts and nuts to this. Set screw to hold them down in position. So that's it. So this forms your burner unit. Thanks very much for watching this video. Like, subscribe to our channel and share our videos. Thank you. So save everything else. Okay. Show the camera. Bye. Alright. So we've taken our time to design all the necessary parts. So what we'll be doing in this video is to assemble the whole stuff. Alright, so you go to new. This time around you'll be clicking on assembly and you say okay.
What we used to do for would get close.
Yeah. Back now. Okay. So the first component to put is the mainframe. So I just want you to observe what happens as you drop the mainframe. You observe that the screen, Solidworks automatically moves the frame into an already existing location, but that is not your location. The reason why you need to do this is that we are trying to generate the 2D drawings. This location is not actually synchronized with the front view of the assembly. You see, the assembly environment has the front view, the top plane, and the right plane. Likewise, the component you just placed in has its own. So your first what to do is to align the assembly front plane with the component for the front plane, majorly which is the mainframe. We bring the mainframe because it's the stable part of the machine, the stationary part of the machine. So you say front plane, mate. So you come here to the design tray, you drop it down, mate it to the front plane. So automatic coincident relations is added to it. You can see it, then you mark it. Then you go to the top plane, then you move to the top plane of your product, then you mark it. Then you go to the right plane, then you go to the right plane of the product, then you mark it. These are first three mates is the very fundamental mate you have to make anytime you're doing assembly. Then you right click on the component again and you put fixed. So the component is fixed at that location. Then so it cannot be moved. You see, the component cannot be moved. You can rotate it and see different dimensions. So from here now, the next thing to add now is to bring in the mainframe of the body. So you go to assembly and say insert component, then you move to this place. So the burner unit, the whole burner unit has been assembled before as a pre-assembly. So we will be bringing in the assembly of the whole burner unit. So I'm bringing in the assembly of the whole burner unit. Alright. So the desire is that this particular hole will set with this hole, and this particular surface will flush with the top surface of this place. So let's start. So I click on this place and I say mate. Mate with where? Mate with this place. Alright. So you check that's the right way you want it to be done. This hole, this circle must be concentric to this circle. Yeah. So you have this. Now, one critical thing you need to observe here is that this particular sub-assembly can still be rotated. So you want to position it in one particular place. So I want to position it that way. So I will go to my sub-assembly I just added now. I want to locate all its relevant mates. So I will make this right mate, the front plane of the assembly, and we have it there. So it means all the air filters that was added. So I'll be putting in the air filter 1 first, which is the most inner one. So Alright, so there should be a concentric mate between this surface and this surface. Likewise, this pillar should be sitting directly on top of that surface. What we'll be doing is that you drag it up this way, and you will put where it's supposed to sit. That's the place of the plate. And then you turn the whole thing out again to locate the second surface in question. And then an automatic coincident relation. Then you add the second technique. Concentric relations. Click on the surface. So you click on this surface. You click on this surface and you click on the other surface, other circular surface. Then an automatic concentric relations is added. You click this particular surface because your aim is that this air filter should sit directly here. Then another concentric image is added. So the last thing you have to add here is the third air filter. So you add the third air filter. Then you add a concentric relations to it. Mate with this. Add the concentric relations to it. And try and raise this line high. So now I'm exposed to this line. So from experience, we discovered that this was not well positioned. So I'll be showing you something, how to edit a component in assembly. So click on it and it says edit part. Okay, I have to save the assembly. So let's name it kerosene. Kerosene stove. So the revolve that was used to generate this particular component, I use revolve in generation. So you go to your design tree, you will see the component in question in blue color, then you can open it and do any editing work you want to do. So is this particular thing you want to adjust? So I'll make this like 130. Then I'll make this one inside, the second one inside. And then I'll choose the next one. Update. So you can see the way it behaves even before your assembly, before you return back. So that's the way it should be in real life. Alright, so the next thing to add now is to add the cover of the stove and the stove skirt, the pot skirt, where the pot rests. So I'm adding the cover and the quad skirt. 1 and 2. Alright. So it is designed in such a way that this particular surface will meet this particular surface. An automatic coincident relations will be added. Now, the desire is that this particular surface will be positioned appropriately. I will not be using advancement for this job. Let me just use a normal method. Make this particular solutions to this surface to this place and this surface to this place. Similarly, we make this surface to this surface. That's that one. Then the next thing you have to do is to make this surface this particular edge. Centric relations and coincident relations added. Then make sure that this circle is concentric to this edge. And if you have done that, you have finished the assembly of the whole stuff. This is how it looks like. I think it's an awesome. If you like the video, you can subscribe to our channel to view more important videos. In the next video, we'll be showing you on how to run a wonderful animations, how to do some critical check on Solidworks on any of your products for interference or all other things to check on any product design on Solidworks. Stay tuned.